Bismillahirrahmanirrahim. HRW 10 edition extended chapter number 15 oscillation problem number 13. An oscillator consists of a block of mass 0.5 kg connected to a spring. When set into oscillation with amplitude 35 cm, the oscillator repeats its motion every 0.5 seconds. The oscillator consists of a block which is connected to a spring. Three things are given. One is the mass of the block, which is 0.5 kg. The second one is the amplitude of the oscillator, which is 35 cm. And here we convert centimeter into meter, so 35 cm is equal to 35 multiplied by 10 raised to the power minus 2 meter. And the third one is that the oscillator repeats its motion after every 0.5 second. Now we have to find the time period, frequency, angular frequency, spring constant, maximum speed, and the magnitude of the maximum force on the block from the spring. Solution part A. As the oscillator repeats its motion after every 0.5 second, and in simple harmonic motion, a body repeats its motion when it completes its one cycle. It means that the block repeats its motion when it completes its one cycle in 0.5 seconds. And the time required to complete one cycle is called time period, so time period is equal to 0.5 seconds. Solution part B. As frequency is the reciprocal of time, so frequency is equal to 1 divided by t. By putting the value of t, frequency is equal to 2 Hz. Solution part C. As we know that angular frequency is equal to 2 pi f, by putting f is equal to 2 Hz, angular frequency is equal to 12.6 radian per second. Solution part D. Now we have to find the spring constant of the spring. As we know that omega square is equal to k divided by m, or k is equal to omega square m. By putting the values, k is equal to 12.6 square multiplied by 0.5, which is equal to 79.3 Newton per meter. This is the spring constant of the spring. Solution part E. Now we have to calculate the maximum speed of the block. As we know that maximum speed is equal to omega xm. By putting the values, Vm is equal to 12.6 multiplied by 35 multiplied by 10 raised to the power minus 2, which is equal to 4.41 meter per second. This is the maximum speed of the block. And remember that in simple harmonic motion, the maximum speed of a body occurs at mean position. Solution part F. In this part, we are going to calculate the magnitude of the maximum force exerted on the block from the spring. As we know that F is equal to kx, here k is the spring constant. It means that the magnitude of the force exerted on the block from the spring is directly proportional to the displacement. And at maximum displacement, which is called amplitude, the force exerted on the block from the spring will be maximum. So magnitude of maximum force is equal to k xm. By putting the values, Fm is equal to 79.3 multiplied by 35 multiplied by 10 raised to the power minus 2. After calculation, magnitude of the maximum force on the block from the spring is equal to 27.7 Newton.